Welcome to this year's Global Science Summit, hosted by the United Nations General Assembly concurrent with its 79th annual meeting. Our moderator today is Shelley Brunswick, a futurist and a renowned expert in the global space ecosystem. Shelley shares her ideas and insights with us today. Her now famous tagline starts us off. Shelley, what's space got to do with it?
Thank you so much, Kim. Good morning, good afternoon, and good evening to everyone around the world joining us. It's a pleasure to welcome you to today's session of What's Space Got to Do with It? Innovations in Earth imaging satellites, space data, and GIS mapping. I'm thrilled to join Kim for this dynamic discussion. As she said, I'm Shelley Brunswick, the CEO and founder of SB Global LLC, and I did a TEDx talk in 2022 with this exact same title, What's Space Got to Do with It? So it's an honor to moderate this distinguished panel along with Kim, where we will explore the transformative role of space technology in enhancing global sustainability, health, and security. Today, we're joined by a panel of exceptional leaders and innovators from across the globe, each bringing a unique insights into how space data and technologies are being utilized in their respective regions or industries. Their work is not only advancing our understanding of the Earth, but also helping to address some of the most pressing challenges of our time. I'm excited to hear from our panelists and engage in what I'm sure will be a dynamic discussion on the future of space technology and its potential to create a more interconnected and sustainable world. I'd like to start by introducing our first speaker, Masami Onoda, from the Japanese Space Agency. She is the Director for International Relations and the Research Department. Thank you so much, Masami, for joining us.
Thank you for having me, Shelley, and thank you for the kind introduction. And thank you for the organization of this great panel to Kim and all speakers as well. I would like to start my presentation and I will share my screen. Let's see if I can, does that work well? All right. So today, to kickstart this wonderful panel, I'd like to do my short presentation describing what we're going to talk about today, and also what JAXA, the Japanese Space Agency, is trying to do along with our mainly Asia-Pacific region colleagues and also globally. Let me move on to first starting with the United Nations Space 2030 agenda. This promotes the use of space-based solutions for the achievement of the UN sustainability goals. And the objectives of the Space 2030 agenda are based on 4 pillars, including space economy, space accessibility, space society, and space diplomacy. And as concrete projects, it does involve, as you can see on the slide, the UN Spider, Space for Water, Access to Space for All, and Register of Objects, which is really becoming an important role, and space law, and all these areas do promote the SDGs, as we know. Now, going on to the JAXA projects, you can see our fleet of satellites here. I would like to name especially GOSAT. That is now a series. The first one launched in 2009, the second one 2018, and now we're working on the third one, which is on the lower right side. GOSAT GW, it's named because it combines different sensors for the water cycle and greenhouse gases. Now, as a satellite dedicated to monitoring greenhouse gases, this one is a very special globally monitoring satellite, and it has been running for now, you can see, many years, compiling data that can be used for international multilateral efforts, such as the UNFCCC. Also, others include our radar satellite for disaster monitoring, EarthCare, that was just launched this year in May. It's a cooperation with the European Space Agency for cloud and aerosol observation. And all of this is really the science and everything, and is done through international collaboration. And that is another point that I would like to make. For instance, GPM, shown on the left, is a long-standing cooperation with NASA of the United States. So international cooperation is a pillar to our efforts. Just to show you a brief image, and this is just is not enough to show the wealth of data that we have, but the animation I thought would be easy for you to see that the time scale and the global nature of the data that the GOSAT that I just introduced to you gathers. And this, as you can see, is impossible to do from ground by human ground observation. So combining ground observation and space data as such is making a really phenomenal leap in our greenhouse gas concentration monitoring. Another example I wanted to show was CH4 rice. Of course, that means methane. It will take some time to explain the whole mechanism to you, so I'll cut that short. But in very short, the rice paddies level of water does very much influence the emission, the amount of emission of methane from that rice paddy. So we are cooperating with our Asian country colleagues, space agencies, and other organizations, institutes, to monitor from space the level of water in the rice paddies and map that, and then put that into a model and try to monitor the CH4 emissions, which is a crucial greenhouse gas that has to be monitored for global greenhouse gas monitoring and climate change. So this is another project that we do for capacity building. The examples are for Guatemala and Mauritius. We have a function to deploy small microsatellites from the space station from our Japanese module. And this has this cooperation with the United Nations Office for Outer Space Affairs to deploy microsatellites for these emerging countries has been a great effort and opportunity for these emerging countries. So that was my short presentation. We do have a lot of initiatives for SDGs and a website also. Please visit this, and I'm happy to join the discussion in the following session. Thank you. Shelley, you're muted.
Muting.
Good.
Thank you so much. We've learned that. Unmute yourself or mute yourself. It can go both ways. But I want to thank you, Masami. That was very insightful. And I think the part that you've highlighted also is that space technology is very beneficial for Earth observation and looking at climate change, but you and your particular role of the international collaboration, how we work together in space, how we share data. As you said, we have a lot of orbital debris. We need to work together to mitigate that. One country, one company cannot just go and remove all that orbital debris. One country, one company cannot solve climate change. And so I think it's really important in the role you're in JAXA now in the international relations area, that it is how we work together collaboratively as humanity. So again, I want to thank you for your time and for sharing your slides. And I know it's you may have to step off, but if you are able to stay for a few questions later, we appreciate that. If not, I know that you have a busy schedule today. So thank you so much.
Thank you. I think I can survive until midnight here in Japan.
Thank you so much. Next, it is my great honor to introduce Dr. Hudong Guo, the Director General of the International Research Center of Big Data for Sustainable Development Goals. Thank you so much, Professor, for joining us. It's our honor to have you with us.
Thank you. Thank you very much, the moderator, Shelley. I came from, the International Research Center of Big Data for Sustainable Development Goals. So our mission, one of them just launched some satellite. Already, we launched a lot of satellite, but in recent years, we focused on, launch the SDG satellite. Why everybody know that, for the SDG indicator, we needed to monitor, to evaluate, to assessment for that. We need the data. So data, observation data, remote sensing data, space the data is really, really important. That means the satellite data is a very important one. So just for this reason, just because, the satellite data can cover, global coverage. So we total have the 17 goals, but about 7 SDGs can be monitored directly. But all, SDGs, total the 17 SDGs can be supported indirectly. So Earth observation satellite data is so important. Just for this reason, just 3 years ago, we launched into the space the satellite we call the SDG and Sat-1. SDG Sat-1 total, we have the 3 sensors. The first one is the glimmer sensor. The second one is multispectral, and the third one is thermal infrared. For these 3 sensors, we can monitor the indicators, from night to day, total for 7 goals for more than 20 indicators. Just to give you some example, you can see at 11's sustainable cities and communities. So we use the glimmer data to monitor for that. This is the nighttime light products, we can identify the different kind of urban communities. So it's really, really useful. Recently, we published the atlas about the glimmer atlas, so people can use around the different regions and different countries. Second, some example is about the SDG 13 is climate action. So, we just use SDG Sat-1 thermal infrared because we have very high resolution. So detecting the ice lead, just using the thermal infrared the sensor, we detect a lot in some polar regions. And another example is about SDG 15, life on land. So by using the SDG Sat-1 thermal infrared data, it tracks the different sandy desertification levels in North China. That means we can monitor the city car directly by the thermal infrared the sensor. So where they have the desertification, where we can monitor for that, not only for regional but for big area, even some for global monitoring. It's very, very useful. So satellite data, we have a lot. So we can do analysis, we can do monitoring and evaluate the indicators. But a very, very important one, we should share this data. The satellite, operate along the Earth's orbit. So every day we get a lot of data. So we encourage people use this data. For this reason, we initiate, the Open Science program. Open Science program, that means we can share this data globally for the free of charge. So people around the world, if you apply for this, data, if you have some, indicator, you really want to use it, you can get some research result. We can provide this data freely. Here you can see in the past 3 years, so far already, we get about 360,000 things, data, and people and users from the 103 countries use this data. So data for what? For monitor, for evaluate, for assessment the indicator. Here you can see we do some remote sensing environment journal, International Journal of Digital Earth. So far already we publish, with another kind of the journals already published more than 100 journals. That means more than 100 countries people use it, and already just published more than 100 papers by using this ID-SAT1 data for the purpose for monitoring the indicators. Well, so far only we have only one ID-SAT data. You know that that's not enough. So China in the past about 40 years, especially in recent 5 years, already launched a lot of satellites, including like a meteorological satellite, ocean satellite, resource satellite, environmental satellite, even disaster satellite. So they already have a lot of data. So why we should do work together? So we 7 centers just work together. We our center we call CBARS in cooperation with other 6 satellite centers. We established 2 years ago some we call organization Alliance of Sustainable Development Goals Satellite. In short, we call the ISA. So far, ISA have the very rich resources. What does that mean? You mean so far we have just over about the 61 satellites. Total we have 153 sensors from visible to infrared, from infrared to microwave, and passive and active sensors. So we can get a lot of data. That's true. All of this data, some data can be used for monitor the SDG indicator, but some cannot do that. But we use a lot of data. They have played a very, very important role. But how about the future? The future, we want to establish we develop some new satellite constellation. So because we needed it. Already we have other kind of the satellite, but this satellite has a special purpose. We should develop some specific satellite. That means SDG satellite. So already in the past couple of years, our center have completed the program desire for SDG-SAT2 to SDG-SAT10, this satellite. In the future, our purpose is just for, launch the SDG constellation, let the constellation data share around the world, let this data play the more and more important role for monitoring, for evaluating the SDG indicators. Well, thank you so much.
Thank you so much. What you brought up, Professor Gao, is obviously the importance of big data, but also we need that artificial intelligence to help process all the big data that's coming from the satellites. And I know that that's in another session that Kim is convening on space and AI, session 26. But we do hope to have more discussions to further illustrate how space and AI and quantum are tied together. And Professor Gao, I think you highlighted very effectively how important the big data is and then how we can process it for use here on Earth. So thank you so much, Sheshe.
Yeah.
Well, wonderful. I'm going to now move to an industry expert. We had some great insights from government agencies that are sharing data, and I'd like to now pivot to Michelle DeValley, who's a global fellow and the founder and CEO of FinSat. So, Michelle, we'd love to hear how your company is utilizing Earth observation.
Thank you so much, Shelley, and thank you everyone for being here today. I'm truly honored to be here. I'm super excited to represent my company, FinSat. We are a climate risk ratings company, and we are focused at the intersection between land, property, and infrastructure, and helping evaluate risk. So we do that in a few ways, but where I really want to shape our focus here today is really on the visual. And the United Nations, we actually launched last year at the United Nations General Assembly because we wanted to solve SDG Goal 11 and SDG Goal 6. So we wanted to focus on building sustainable cities through the lens of water. So we created a tool called City Lens. And so I'd love to walk y'all through a problem set. So give me one moment. So specifically, the question is, how does Earth observation help impact our visualization of risk and change in a city to solve SDG Goal 11 and 6 together through the public sector, the private sector, and the civilian sector? So I'd like to focus on the problem about how cities are impacted by floods. Specifically, floods cost over $180 billion a year in the US. This is a report by the US Congress Joint Economic Committee. And flood risks are increasingly at high stakes in low to middle income countries, impacting 1.81 billion people globally already today. So I want you to imagine the three main stakeholders of a city, and that's really what the UN SDG goals represent to me, is really giving a voice to the government sector, the private sector, and the civilian sector. So I'd like to walk through how we have defined those three stakeholders. So the private sector stakeholders are focused on businesses who rapidly increase the microeconomics of a given region by catalyzing short-term capital injections to bolster the local economy based on market demands. Civilian sector are the residents who live and work and pay taxes in a city and foster the community. And the government sector is a part of the rules and guidelines and the long-term development for the longevity of culture and for generations to come. So then when you ask yourself, how does a flood impact all three of those stakeholders? So just one day, a big flood. Well, that impacts buildings, causing structural damage, interior destruction, even mold growth in buildings, huge repair costs. Our insurance companies are flooded. Land is causing our waterways to be polluted by runoff from specific agricultural pollutants, as well as our storm drain systems and infrastructure cannot withhold the floods as well, and that also pollutes our waterways. So as I say all of this, it's a bit overwhelming, right? And a lot of information, and that's really where climate often comes to play. It's scary and it's a lot of risk, and how do we deal with that? So that's how we leverage the visual, and one of our components of City Lens really focuses on digital twins to produce live simulations of our predictions, where we incorporate satellite data, building level data to create long-term predictions of specifically flood-related risks. So you can actually visualize this in real time. So I'll walk you through an example. But first, I really want to ask, like, what are the solutions? Specifically, we use physics-based simulations to predict capital loss on buildings using satellite imagery, radar, building and land data using deep learning models. And then we asked ourselves, if we just show y'all the numbers, is that really enough? Does that really connect all three stakeholders? And we don't think it does. We think a picture is worth 1,000 words, so how about a movie? So we proposed a solution that connects all of us through the power of Earth observation, visualization, and live simulation as a way to access predictive risks, to assess proper mitigation strategies that meet each stakeholder in a city's agenda. So imagine all being at the table, being a civilian, a government agent, and a private sector representative. And let me walk you through just an example of a short clip of how we have proposed to level the playing field before diving into the data. I'll quickly show this. Presentation. Okay, so y'all can see my screen and hear me.
Yes,
so
we can.
This is Lower Manhattan, and this is a multi-decade simulation where we are starting to show flood due to sea level rise and buildings starting to turn red. You can see that the flood is not consistent. That's due to different flood inundations and the topology of the region. And so you're able to really assess the risk just through a visual cue. And this is a very short clip, but we just wanted to leave you with that frame of reference in your mind, and how you communicate satellite data and observations can really be at the citywide level and can be a communications tool to connect all three stakeholders in a city. Thank you very much.
Well, thank you so much, Michelle. That was really insightful. And I think it applied to, we have some individuals that are listening in, such as Lumbi Malambo, who's a convener for another panel, but she is the ambassador for water and does a lot of things about water. And I know Mishak will be joining us. Mishak Kinyua will be joining us next. But there's been a lot of flooding and drought in Africa, but around the world we can see a lot of flooding. But I know in Cameroon there's been excessive flooding, Uganda. And so as it's able to predict these weather patterns, that can really help to protect people and crops. And I know when Dr. Catherine Nakalibi joins us, who is the Africa Director for NASA Harvest, this type of information is very valuable for her administering her program too, to help farmers in Africa not plant, save their resources if there's going to be flooding or droughts that's going to damage their crops, and then use those resources in other ways. So thank you, Michelle, for providing this amazing insight on how digital twin, the AI predictive tools are helping us plan not only today, but into the future. And I really think that's valuable for this session. So again, thank you for your great insight and adding to this. As I kind of highlighted, my next guest is Mishak Kinyua, and Mishak is the African Space from the African Space Agency of the African Union Commission, and he is the leader for training on space and emerging technologies. So Mishak, we're so excited you could join us and share more insight on what you're doing in Africa and the partnerships you've built and created. So thank you.
Thank you, Shelley. This is wonderful work that you're doing to unite all of us and talk about the initiatives that we are conducting in different continents. And I'll draw the inspirations from the previous speakers and talk about what we are doing in Africa and applying the Earth observation as well as other data sets to infuse into decision making. And I won't dwell into this first part of the presentation, but just to mention that we have a long-term agenda called 2063, which we call the Africa We Want by 2063, and it's it's crafted in 7 inspirations or aspirations, and in each of the aspirations there are goals that we want to get there. And to help us achieve all these goals, just like it is true for the SDGs, so it is for this agenda, that all the aspirations that we have, a majority of them can be tackled through space. I'm hoping you can see my screen move. So I'm going to talk about the appropriating space for socioeconomic development, which is the main language that decision makers would normally like to hear, and the innovations in the systems that have prompted, these evolving societal needs. And I'm going to have a laser focus on a project that we are implementing called Global Monitoring for the Environment and Security in Africa, GMES in Africa in short. It's a collaboration between African Union and European Union on application of Earth observation information. And it's not only Earth observation, as we are going to see, it's a whole group of data fusion from different sources. I would like to talk about the 2 services, the ocean and marine services, as well as the water and natural resources. But I think in the interest of time, I'll just dwell on the ocean and marine services. We are working with a number of consortia across the continent. For those who don't know Africa, it's a continent made up of about 55 countries. And these 55 countries they're all different in their own right. But we try to they're all united by different factors, like, the challenges that we go through, the societal problems that we are trying to solve. But they do have their own differences in terms of their nationality and priorities. So I will present about 3 main services, which is the fishery service, the oceanography service, and the coastal service, and how we are applying the data. So the regional, for the oceanography service, this is a service that we are developing with our partners. We have about, this project is in the 2nd phase, I would say that, and we started off with 12 consortia of institutions, which all together make a network of close to 200 institutions. And these are national and regional institutions. And in the 2nd phase, we brought that to 8 institutions or 8 consortia, maintaining the same network. And for this oceanography service is being tested in West African region and the North African region, which is a huge marine ecosystem. And what we have been doing here is to apply the satellite observations to inform what we call the marine weather or the ocean weather patterns, and that helps the fishermen and all those who depend on the marine ecosystem to know what is the situation of the weather in the ocean. So before the service began, the fishermen used to go into the ocean without proper information, and that would lead to a lot of death. And a lot of loss of properties, their canoes, and as you know, most of them are artisanal fishermen, and they don't have a lot of systems in their canoes like AIS information and the infrastructure. So we came up with this service to save the situation. And we provide 3-day weather forecast on the ocean, and we put it into just like the traffic lights that show green, red, and yellow. So the green means that the weather is good to go and you can start planning on your fishing or your business in the ocean. The yellow means that you have to, it's a little bit risky and you have to be cautious. And the red means it's a no-go, which means that the weather in the ocean or the sea is not conducive enough. So we have deployed this over mobile services. For those who have Android, we work with the fishermen community, and they have their own leadership. So we communicate that information to the leaders, who then convey the information to the fishermen community. They can have an application for Android owners, or they can have what we call the SMS or the USSD codes for those who don't have smartphones. And this service has worked. We have subscribed about 500 leaders of the fisher community, and it's deployed in 18 countries, like I said, in West Africa and the North of Africa. So this is again a highlight about 3.5 fishers in West Africa with an estimated fatality rate of 1,000 per 100,000 fishermen. That's a huge number of risk that we are mitigating. This is just an example of how the SMS looks like. The USSD code, it says GMS in Africa Ocean State Forecast for 28th November 2023. One, it's calm. Two means, and there are flags that are associated with this so that people can see what is the state in the ocean. So before the service, we used to have about 168 deaths per year, number of accidents 168, and number of deaths about 52 per year. But in 2022, after deploying this service for about 1 year, this number of deaths have reduced to just one, which is significant. But we would like to have and reach a situation where no one has to lose their lives in the ocean because of lack of information. And the number of canoes and nets and outdoor motors that have been damaged, that has reduced a lot. So as we can see, the utilization of this service has helped a lot. The next service that I would like to talk a little bit more is about the oil spill service. There are some cases of oil spills, which continue to pollute the environment. This service was deployed after a study that was done to appropriate the needs again on the North African region as well as the West African region. Since the deployment of this service, the total number of oil spills that have been detected so far is 71 cases. And the total area covered is about 2,071 square kilometers, which means that we are able to mitigate before it happens or even inform decision makers. The next service that I would like to talk a little bit is called shift traffic monitoring. There are lots of what we call the unregulated and unreported illegal fishing, which happens a lot on the coast of Africa. And this is also informed by the need to improve the surveillance of these vessels and enhance coordination for enforcement of policies and rules. So we identify and protect sensitive and unique marine habitats and species. And this is what we have been able to do for this service. Again, it's covered over, this service is in the Southern African region, but it is, there's work in progress to extend it to the entire coastline of Africa. As you know, Africa is surrounded by water, and therefore there's a huge community that dwells and depends on the livelihood of or the marine life, which is our own interest to keep them from dangers and from the vulnerabilities that exist. So the ship traffic monitoring, we have developed an interactive web viewer. There's a vessel detection API platform, and then there's a vessel tracking application as well. And all these layers are added into what we call, the web viewer is like a catalog, or what I would say a geoportal that allows you to draw the data and also see the full service, and you can visualize that. So again, combination of different data sets, including machine learning, is very important. As you can see from these photos, we were detecting, the ship, the vessel, movement from the east side of the continent on the Southern African ocean waters to the to the western side. And this is just to highlight, how we infuse the data sets, extending the footprint, and how we use the AIS data. The AIS data would be considered as in situ information, and we overlay that with the satellite measurements to come up with the detection and the information. And then we go all the way to develop APIs that allow the end user to interact with the web services. Data to policy, this has helped a lot. This service has, as you can see on the picture on the left side of the screen, this is the area of coverage. Again, it is the West African side as well as the North African. We have 75 recipients of this service so far, and these are national institutions with mandate to enforce any kind of directive. And the service has enhanced visibility of the vessels operating within the ecosystem of the Gambia. And I would like to highlight Gambia, which is in the West African side, because from moving from data to policy, this is a good case study. So the result that we have gathered from this particular service in Gambia is that they implemented a fishing ban commencing at the baseline and extending to at least 1 nautical miles, as well as a 6-month period for biological rest spanning from Bijou Island, it's an island in Gambia, to 2 nautical miles. And this has become a regulation, which is one good use case for using the Earth observation to decision making. Again, the fishery service is another important one because about 60% of the global catch originates from artisanal fishers, and these are small-scale fisheries, mostly informal in nature. So I won't go into the technical details of it, but so far we have been implementing, the forecasting, the small vessel fisher over the reefs and with limited communication, because most of these canoes, like I said, they don't have sophisticated infrastructure like the AIS infrastructure that will be required for any distress call. So small-scale fisheries support global food ecosystem, but they lack the formal recognition and governance access to critical supporting technologies. And this was our entry point to provide this fishery service. This is just an example again on the southern side of Africa, which has it's a huge EEZ on the African waters. So we integrate the information like the satellite information, yes, but also the other measurements which are in situ, like wind, weather, air temperature, and so on. We also have some other measurements that could come from buoys and other in situ instruments that are used in the ocean, and we combine all this data to inform us on the decision making. And you can see from the picture on the right the kind of information that we get out of that to inform the decision. So we have successfully integrated the Copernicus data information into the application. We have been producing, record of artisanal fishermen effort and catch, and this data is very important for decision makers and for enforcement of policies. And this is seeing, increase in the revenue because improved market access through some of this application allow us to reach a wider community, including those who want, the products from the ocean and sea. The sea and rescue service is very important. Again, we have incidences where properties and people are lost in the ocean and we need to rescue them. So the sea and service rescue has worked over time and it's being implemented again on the southern side of the continent, but there's an effort now to extend until the West African coast. So we support sea rescue officials by providing real-time information, calculations, and location of objects. There's a web portal that is existing to allow, these decision makers access the information. We digitize all the drift calculation and objects, specific coefficients, and other measurements that are indeed useful for delivery of this service. And then we provide the information to these enforcers or decision makers. So in terms of, I wouldn't say innovations per se, because we have dwelt only on the service, which is a critical part of the Earth observation ecosystem. But I would say that, I would call them nuances that we have been doing. One is to incentivize the citizen participation. We have been doing a lot of crowdsourcing to provide the in situ measurement, but also to collect feedback on the usage of these services. Gamifying some experiences to make it more engaging. This has been useful to allow the adoption of these services to the communities. We have been automating validation mechanism for data collection, integrating other data sets, which is the data fusion part. We not only dwell on the Earth observation from satellites, but infusing that with the in situ measurements, which helps us to validate some of these services. The crowdsourcing is very important for community engagement. It allows us to, co-design and co-develop these services with the user community, which at the end then allows them to understand exactly what services we are providing. It's for some time we have been we had been doing a lot of technology push, which was met with a lot of, resistance from the user community. But with engagement of users and co-designing with them, they appreciate the services and they use them appropriately. It has not come without challenges. Of course, there are many challenges we are navigating. One of them is the integration of the different data sets, multi-core and in situ data. It has, its own challenges, but we are navigating this through the technical resources that our institutions are working together, and they're working in concert and in collaboration, which is important. Difficulty in obtaining some USSD code in some countries. It's an issue because you have to work with the mobile or the telecom providers to ensure that the service is operational. Limited penetration of some services beyond national focal points. This is calling for engagement with national focal points and the users. I mean, these challenges, we also see them as opportunities for us to develop our services and make sure that we are enhancing them every time. I would stop here, but I would also like to say that like Professor Guo said, that the most important thing is about data sharing. Data sharing is very important beyond the confines of the territories that we are measuring them. And I would say that for the past 2 weeks, we have been in Brazil under the G20 convention. We had a meeting of the space economy leaders last week, and what came out is a resolve for space agencies to be sharing data and information to ensure that we tackle the climate change, the challenges in concert. And this is important because climate change, it has about 55 essential climate variables that are measured both from space and from the Earth measurements. And we realize that more than half of them are actually measured from space. And these are, ocean parameters, they are land parameters, and they are atmospheric parameters. And therefore, they require huge measurements from space to concretize the details that need to go into the absorption of those models. So I would like to stop here and encourage us to work together, both companies and institutions, in order to achieve the SDGs.
Thank you so much, Mishak. And I think that was a really good tie-in, like you said, with Professor Gao and the big data and AI, as well as Michelle showing those applications from the industry. And what I think is so great with the African Union and the activities you're doing and covering 54 countries in Africa and what you're doing, I know that Dr. Sharif with ISESCO, which is the Islamic World Educational, Scientific, and Cultural Organization, ISESCO, they also have 54 member countries, and some of those countries overlap in Africa. And so I know the work that Dr. Muhammad Sharif, who's the director and advisor for science and technology at ISESCO, some of his amazing work that he does, not only with helping entrepreneurship, but helping with climate change, sustainability, and farming and agriculture, are very applicable to some of the work you're doing, Mishak, as well as some of the data that Professor Gao shared. So thank you so much. And again, Dr. Sharif, thank you so much for all you're doing with ISESCO, not only in Africa, but with your other member countries and other countries around the world, and the floor is yours.
Thank you very much, Ms. Shelley Brunswick, Ms. Kim, and also all the participants and the speakers. It is a distinct pleasure and honor to join you at this thoughtful session. It is always a pleasure having you the moderator and also learning from your thoughts. Yeah. If you allow me, I would try to share the slides, and if there is some problem, then I can speak without slides. Is that okay?
Are you able to share? There you go. I think you're sharing. Everything's working. Perfect.
Okay, that's great. I just want to, I have 5 minutes or 10 minutes because I've seen that Michelle had taken a lot of time. So
that's okay. Please, we'll be flexible with your presentation. So 5, 7 minutes, 8 minutes, that is fine.
Okay, fine. Thank you so much. Yeah. We are Islamic World Educational, Scientific, and Cultural Organization. We are a little bit different from the space ecosystem. This organization is the 54 member countries around the globe. We, as Shelley mentioned, that we have like 17 countries are our member from Africa, 22 the Arab region, and we have like 14 countries from Asia and Central Asia, and 2 countries in Latin America. So it makes us 54, and our presence on 4 regions. We have the different sectors. We have the science and environment sector, education sector, and we have the cultural sector, and corporation and international relations. These are the main sectors. Then we have several centers and departments. We are based as a headquarter in Morocco, in Rabat, and we have also regional offices in Tehran, Sharjah, Baku. In addition to this, we have like around 15 centers in different African and Asian countries. We actually, you can consider us, ISESCO, as a UNESCO of the Islamic world. So the same mandate in education, science, and culture. We didn't have anything to do with the space in the previous years. However, with the great support and also with the great help and inspiration from Ms. Shelley Brunswick, not only we created the new department at ISESCO, we call it the ISESCO's Outer Space Department, but also we stepped into the awareness programs, technical programs, and also the training programs on the space and about the space. The first efforts we did with Ms. Shelley Brunswick when she was the CEO of the Space Foundation, we called it ISESCO Global Space Science Forum, where we gathered like 43 countries and 43 space agencies actually. And even it was the era of the COVID, but we did well. Then we started a series of the Aerospace Symposium and CANSAT Model Satellite training workshops, also with the help and the support of the Ms. Shelley Brunswick and the colleagues. First CANSAT Model Satellite training workshop was held at ISESCO headquarters in Morocco, where the 23 countries sent the participants. Then the next was in 2022, it was happened in Burkina Faso. And then last year, we did it in the 3rd edition of ISESCO Global Aerospace Symposium and the training workshop. You know, this during this workshop, this training, Aerospace Symposium, we tried to bring the first day the leading experts and also space agency heads and also the former the head of states. For example, Sheikh Modibo Diarra, the Prime Minister of Mali, he's a NASA scientist, so we brought him also, and the astronaut Sian Proctor. In all the 3 editions, she was there, and of course, the chairman of Turkish Space Agency, chairman of Pakistan Space Agency, and also Azerbaijan Space Agency. We all gathered in Turkey and also on the other occasions. Why I'm just telling this, that what we are doing this, we are creating, the first thing is awareness. We believe on 3 A's. The first is the awareness which we bring to our member countries through the symposia, conferences, and the summits, which we organize by ourselves, and also we support financially and also technically. Then it goes to the MOUs. This is called acceptance. Acceptance is like when the people are believing, we do this like we did with the Space Foundation. And then we took also one the certification course from Space Foundation, Cosmos to Earth. And couple of dozens of the people, students, they got the benefit of it. Then we are also we have the MOU and then closely working with Milo Space Science Institute. Then there is the ISNET, Inter-Islamic Network on Space Technology. 18 space agencies are the member of this network, which we have now the MOU, and then we are supporting the international symposiums and trainings, etc. For example, with them, we did the training workshop on disaster management and debris management, and also on the multi-hazard vulnerability and risk management. Then following this, the MOUs, we had several the space entrepreneurship workshop in Oman. Then we also try to bring the opportunities to the interested people, to the students, particularly the young women and girls from our member countries, and even now the beyond our member countries. We participated in IAC, in an International Astronautical Congress last year, with 500 participants from our member countries. We brought the 200 from the Africa and gathered them here in Morocco, and then brought them through the chartered plane to Azerbaijan, Baku, and then 300 we gathered from around our member countries. We are also trying to do some of the action and tangible activities with different space agencies. For example, we are doing the drone technology and space technology, the use in forest management, the training workshop at a ministerial level with Oman and Saudi Arabia. Then we have also the space medicine training workshops with other Cosmos, and then currently we are in a discussion with United Nations Office of Outer Space, UNUSA, to have some of the space policy and the training workshops in our member countries. These are some what I wanted to share with you people, and then also we are planning to in the coming years to launch a satellite, ISESCO CUBE satellite in coming years for the education purposes. This is our efforts and then our contribution in the last couple of years. I would say like 3 years, you can say, towards the application of the space, or as your session named, that what the space got to do. But so this is what we are trying in our member countries, and looking very much forward to work with the partners, mentors, and also the supporters of this cause. We are also going to participate in the COP29 as an official observer, and then we'll be also taking part in the Space Leaders the forum on 16th of November. These are the few initiatives what we are working on, and also we have started at ISESCO one program. We call it ISESCO Accelerator Program, to train the startuppers, and then we have also put the space as one of the verticals, and looking very much forward that how we can make it more available for the people coming from our member countries and the interested students. Ms. Shelley Brunswick is very well aware of our efforts, which we have made in the last couple of years, and then also our endeavors in the future. So I thank you all for this opportunity and listening me. And I'm very much looking forward to see your views. Thank you very much.
Thank you, Dr. Sharif. It's always a pleasure to have you join us. And as you shared, you're doing a mass amount of programs. And what's so really critical is that there's a lot of overlap with some of the other presenters today in regions of the world. Obviously, we have Victoria from Chile and Mishak from Africa and Masami from Japan and Dr. Gao. So there's a lot of overlap. And I really like how what you're really doing is taking space technology and using it so that people benefit. It's creating inclusivity into technology and understanding of how space is bettering our everyday lives. And you embody what space got to do with it with your presentation. So thank you so much. And I'm sure there's some collaborative partnerships that will spur from this panel discussion. I'd now like to pivot to another one of our industry leaders to share how industry is applying space technology and Earth observation. So I'd now like to introduce Edward Gee, who is the CEO and co-founder of Athero. So Edward, over to you.
Got it. Absolutely. Hi, my name is Ed. I am the CEO and co-founder of Athero, where we are working on building a network of space processing satellites that will enable EO providers to process data in orbit, share that data around, and enable seamless 24/7 connectivity between orbital platforms and orbital and the end customers for that orbital data, be it government agencies, commercial customers, and NGOs. So ultimately, we boil down to one thing. Why is space edge processing important? Why do we need space data processing? So space satellite data nowadays is critical for supporting the UN's Sustainable Development Goals through three separate methods. One is Earth observation, remote sensing for use cases like agriculture, forestry, climate monitoring, emissions monitoring, and EO data makes these efforts more effective than ever. And second is telecommunication. By connecting the world and its population, satellites enable cheap and universal access to the internet, cellular networks, and effectively education and information to the entire world's population, no matter what nation or what region you're in. And the third is more focused on energy. R&D into space does have massive ROI when it comes to improving the lives of people on Earth. And no greater place can we see this in such as in areas like solar energy, where investment into space, improving the efficiency of solar cells in space, has led to massive leaps and bounds in the efficiency and yield of solar farms on Earth. But satellite data does have one issue, in that managing data from space is very, very expensive and difficult. So the typical satellite in orbit in LEO is usually connected to a ground station for 5 to 15 minutes of each 90-minute orbit. All the while, it's collecting a ton of data. This leads to massive data backhauls, massive latency costs, massive bandwidth costs for customers and like different satellite operators, because you have all of this data, like hundreds and hundreds of gigabytes, and you all have to cram it down and send it down within like a 5 to 15 minute contact window. Not to mention, most of the data that you collect as a satellite operator is going to be irrelevant or useless. It's going to be obscured by cloud cover. It's going to be otherwise unusable. It's going to be very jumbled from the suboptimal line of sight when you shoot it down to the ground. And the third issue, of course, is a severe lack of autonomy. I'm sure many of you here have run space missions before, and we all know how difficult it is to have a large flight ops team handling anomalies, handling collision avoidance warnings, handling like ground station passes, and so on. So this leads to massive costs in bandwidth, data storage, latency, and so on, not just for satellite operators, I might mention, but also for the users on the ground. For example, one of our customers is working with an NGO that's focused on preventing wildfires, right? And with the existing system of massive delays and massive data backhauls, it usually takes them about like 3 to 4 hours of lead time before they can warn the end customer of let's say, a wildfire that's just started. But this not only creates cost for the satellite operator, it also creates cost for the NGO, because that means that 3 to 4 hour delay enables a wildfire to become much, much larger, grow much faster, and in the end, become much more difficult to fight. as the space industry grows, so does the severity of the satellite data problem. Our launch rate has 10x in the past decade. Last year, we sent up over 2,600 satellites. This year, humanity is likely to break over 3,000 new satellites launched into space. And even excluding Starlink and these big mega constellations, the US government and UN Office of Outer Space Affairs is estimating about 30,000 new payloads and spacecraft to be launched into orbit within the next decade or the next 5 years. So why is edge processing in space important? We enable, and other space edge processing companies enable massively lower cost for satellite data when it comes to data storage and bandwidth. This is not only because we compress the data before it's sent down, so you don't have to send down hundreds of gigabytes of raw sample files, but also because storing data on the ground is very difficult. So if you have to store, let's say, petabytes or terabytes of data on the ground and have the analysts look through it to find the most relevant bits of the data, that increases your costs very, very massively. And also, not in addition to the latency costs as well. We enable real-time monitoring and response to missions and to customers who are trying to handle tasks like combating illegal deforestation, responding to illegal fishing activities, and let's say the waters of developing nations where we often are dealing with issues of illegal fishing fleets that are essentially preventing local fishermen from being able to tap into the local resources, as well as combating wildfires, combating climate emissions, and securing data from thermal, hyperspectral, and multispectral data to essentially detect methane emissions, greenhouse gas emissions for my bad. Lost my train of thought for a moment. For us, effectively climate emissions monitoring, as well as enabling orbital stewardship and orbital debris removal, space traffic monitoring, space object, space situational awareness, and space empowering space touch to act much more autonomously in performing rendezvous activities, in-orbit assembly activities, as well as disposing of old space junk and old depreciated satellites. So our mission is effectively simple. We believe that by putting computational power in space, enabling data processing in space, and enabling autonomy in space and connectivity from Earth to space, as well as between different satellite platforms, it will enable a new era of sustainability for both human activities on both Earth, in terms of like monitoring greenhouse gas emissions, enabling smart cities, enabling new agricultural advances, and beyond, whether that's disposing of space junk, helping manage traffic for spaceborne traffic, monitoring orbital activities, tracking space objects for a far more greener, far more sustainable human presence in the solar system. Thank you.
Amazing, Ed. Thank you so much. And I think that really ties in really well with the diversity of our panel today of not only regions, but backgrounds from government, nonprofits, as well as industry, and how we're applying this technology and the business case use of it, in addition to helping to lower barriers and create more access and opportunity for individuals around the world to come into the space industry, whether they're using space and applying it to better their lives or they're creating applications. So thank you, Ed, for that concrete example. And I'm going to lead into another concrete example with our next speaker, Paul Dykowitz, who's investment and financial analyst, as well as a writer for Salem Media. So Paul, the floor is yours. Oh, you're on mute.
Sorry about that. But I wanted to thank you, Shelley, so much for the invitation and to be part of this amazing panel of experts. One thing that I can bring to the discussion is the focus on public companies that I have with my job covering investing and finance, and I write 2 columns a week. So one of my specialties has been space and satellites for many years. So it's one of the most exciting areas anywhere. And so many of the new technological advances also tie into what's going on in space. So it's just not on the ground with terrestrial operations, but it's in the air, it's way above us with space applications that are quite plentiful and important. So I'm going to share my screen now, and we'll do the PowerPoint presentation here to help everybody understand what's happening and from my perspective. And let's see, can you see the screen?
Not yet. We'll give it a
I think
second. Maybe it's just slow.
Try one more time. Not the screen I wanted. Let's try that one more time here.
I think, Kim, if you by chance have Paul's slides as a backup, we can have that as a backup.
I do not.
Let me see if I've got this. It worked during the trial. Let's see if I can try this one more
That's
time.
That's why in space we always test, and we did test, so things
And we want
always have
redundancies, absolutely.
Exactly. So
While Paul's working on that, shall we move on and come back to Paul?
we could do that. Is that okay, Paul? We'll move on to our next
That's
speaker,
fine.
and we can pivot back. And so
That's
we have
fine.
we have another great application, and that will be from Tuana Yazisi, founder, chair, and CEO of the Tuana Group, including Aero AI Global Solutions. And so Tuana has both an NGO application as well as a commercial application. And so Tuana, I'd love to hear about your thoughts and insights and your paper and the discussions you've had about how we can use Earth observation to better life here on Earth.
Thank you, Shelley. Well, first of all, thank you for inviting me to be part of the panel, and to all the panelists for the great presentation so far. As Shelley said, I'm Tuana Yazja. I'm the founder and CEO of my holding company, Tuana Group, and its subsidiaries, Aero AI Voyages and Aero AI Design Lab, which focus on developing products and services using AI and space technologies. However, today I'll be focusing on Aero AI Global Solutions, which is a nonprofit I founded, which leverages space technologies and AI to address global challenges. So our work spans 4 main areas: education, research, and design, project implementation, and strategic partnerships. So without further ado, I will quickly share the slides with you all. Perfect. So one of our current projects, Aero AI Guardian, is working toward establishing a robust international system focused on monitoring international human and wildlife trafficking hotspots, developing preventive measures, and ensuring the implementation of appropriate legal actions. And this project aligns with the UN Sustainable Development Goals, and I will refer to them as the SDGs from now on, which are a set of 17 global objectives aimed at ending poverty, protecting the planet, and ensuring prosperity for all by 2030. So space technologies such as satellite imagery and AI are crucial tools in achieving these goals by helping us monitor and address global challenges like human and wildlife trafficking, environmental degradation, and also inequality. So at Aero AI Global Solutions, we believe in the transformative power of space technologies and AI. And our focus areas include preventing human and wildlife trafficking, promoting animal welfare, addressing environmental challenges, and also advocating for international laws. Specifically, our organization will contribute to SDG 15, which is life on land, by protecting ecosystems from illegal exploitation, and SDG 16, peace, justice, and strong institutions, by monitoring human trafficking and providing actionable data to support law enforcement efforts. And additionally, in alignment with SDG 4, which is quality education, our education program will offer scholarships for students in STEM, pre-law, and business with a focus on space technologies and AI, aiming to equip future leaders who will use these tools for global betterment. And we will also provide internships and educational seminars with industry leaders to empower the next generation of problem solvers and innovators. So now the complexity of trafficking cases spanning multiple countries demands an international system to monitor and hold countries accountable. And our project is based on one of my publications called a proposal for the usage of reconnaissance satellites to monitor international human and wildlife trafficking hotspots. It was published in Acta Astronautica 2 years ago, and we're currently adjusting the publication to properly be implementing on an international level. So one of the unique aspects of Aero AI Guardian is its use of space-based technologies, such as high-resolution satellite imagery, synthetic aperture radar or SAR data, and also artificial intelligence to detect and monitor human and wildlife trafficking activities. And right now we're in the process of partnering with international satellite companies to access this critical data, enabling us to track trafficking hotspots in real time. And additionally, we will use radio frequency or RF data, which detects the radio signals emitted by electronic devices, and also automatic identification system or AIS data, which tracks the positions of vessels to help us monitor areas where trafficking may occur. I'm not going to go too much into how these technologies work because we already had a great presentation on that. So these technologies will be integrated with AI systems that recognize patterns and detect anomalies, such as unusual movements or behaviors that could indicate illegal activities. And by applying AI for real-time analysis, we aim to significantly enhance the effectiveness of monitoring and intervention. So one example of how these technologies will be used is to combat illegal fishing, which often overlaps with human trafficking, unfortunately. By monitoring vessels that disable their transponders to avoid detection, we'll track their movements using RF and AIS data. And this directly supports SDG 14, which is life below water, by protecting marine biodiversity and addressing activities that harm both people and the environment. And in addition to international satellite companies, we're also in the process of partnering with top data companies, which will play a key role in helping us process and analyze vast amounts of satellite and radio frequency data, ensuring that we can respond quickly and accurately to trafficking threats. And Shelley did mention the importance of utilizing AI and these sorts of data companies to process these vast amounts of data. AI will also be used to identify patterns, predict trafficking hotspots, enhance raw satellite images, integrate and analyze complex data sets from multiple sources, and provide actionable insights for the investigations of law enforcement. And we are proud to already partner with the Royal Foundation of the Prince and Princess of Wales' United for Wildlife, and we're in the process of seeking government grants to launch a pilot program aimed at combating human and wildlife trafficking. And once operational, we believe the system will serve as a powerful deterrent and provide authorities with the evidence needed to prosecute traffickers. Now, Aero AI Guardian is more than just a project to combat trafficking. It's a comprehensive initiative that aligns with multiple SDGs, focusing on protecting ecosystems, promoting justice, advancing education, and building strong global partnerships. By harnessing the power of space technologies and AI, we aim to create a global system that combats human and wildlife trafficking, contributing to a more sustainable, just future for all. And it's important to recognize and support the many companies utilizing their technologies to contribute to the SDGs. And no single entity can tackle these immense global challenges alone. And collaboration between organizations, governments, and private enterprises is essential to make meaningful progress. And if you'd like to learn more, I have also provided the website of our nonprofit on the slide. Thank you so much.
Thank you, Tawana. I think that was really insightful and a great way of showing the interconnection between sustainable development, as you said, with fishing, but how it's also being overlapped with human and wildlife trafficking. A lot of collaboration and application that could be partnered with MESHAC as well in the activities happening in Africa with illegal wildlife trafficking too. So wonderful insight. Paul, we'll come back to you and see if you're able to share your slides with us.
Any luck so far?
No luck yet.
Okay, let's go on to somebody else. We'll try it again a little bit later.
Okay, what I would like to do then is we'll pivot to another application, which I think is really insightful. We've had industry, we've had nonprofits, we've had academia, and now I'd like to loop in Dr. Catherine Nakalibi, who's kind of a combination of both. She's the assistant professor at the University of Maryland, and she's the Africa director for NASA Harvest, which is a great program. It's not only in Africa, it is around the world, but it's how we use space technology to help farmers. So, Dr. Catherine, over to you. I'd love to hear your presentation.
Thank you. I hope you can see my screen.
We can see your slides.
My slide. Awesome. So Catherine Nakalembe, assistant professor at University of Maryland, and I had to teach, so I've joined a little bit late, so trying to catch up with everybody, but excited for the opportunity to present today. And for my presentation today, I thought I'd do something slightly different, which was to think about taking you on a journey in the future, thinking about, let's say 2050 or 2100, we've resolved, we've kind of solved SDG number 2 in this particular case. So to sort of backtrack before we end up in 2050, I thought to kind of frame my work around how I started. So this is in 2015. I'm standing at a field in Rupa, Karamoja. It is at the peak of the growing season, and I'm observing a field. I'm trying to map it to create a product that we would later on use for, let's say, food security assessment or determining how much aid might be needed to support the community in Rupa. At this point, it's too late in the season. There's nothing much that a farmer can do in order to save their field or harvest a little bit more at the end, because it is the end. Fast forward into 2050, the farmer who owned that field, I use the name Nakiru, who is a woman from the northeastern part of Uganda and Karamoja, same place I was standing. And as she's working in her field, she receives a text message, or which ends up being a voice message. It is telling her that it has important information that she needs to be aware for this upcoming season. The prompt continues to say that risk factors are really high for the season. There's a projected shortfall in rainfall over the next coming weeks, and then a cyclone later on in the season. This is not something that is out of the blue, in the sense that in many regions that experience one extreme after another, floods can precede and or come after a long, prolonged dry period. So the prompt continues and says, would you like to know if there is information available for you that you could use to overcome the upcoming season? So, of course, she would like to know more information, and she would also love to know if the insurance that she has been registered for will support her, and what projected prices for sorghum, which is a staple in this region, are. It is important for her because she needs to be aware. She needs to know whether she can afford to sustain her family's livelihood over the coming weeks, since she will not be able to harvest anything for several months. The prompt continues and says, well, there are government programs, loans, etc., and that your insurance will in fact pay you if you do not plant, because under the clause prevented planting, which means that because they understand that spending your money to invest in a season where it will most likely fail or 90% fail is not worth it. So you might as well save the little income that you have. So the question is, how do we get here? The decision is hard. She has to make a call. And because she has reliable, dependable information through this program or through this process, she knows that she will get support. Her family will be able to survive through to the end of the next harvest. And the government programs that are available are actually accessible. They're not completely made up, or they're too far away that she would not be able to get, let's say, a payout or supplemental food to feed her family. So how do we get here? In order for her to be able to get that text message, there's a lot of sophisticated modeling that depends on extensive data sets, on a multitude of variables that need to be accounted for to predict how severe the drought will be, to predict the level of effort and support that she will need, to predict at what point the support will arrive, and to enable the insurance company make a good decision about paying her if she doesn't plan. So technology in this case that is critical for this component is Earth observations technology. In order to get insights from these extreme, extensive, incredible data sets, we need to be able to analyze them. And some of the work that we're doing through Harvest Africa work through the NASA Harvest program is trying to understand, distill, map, and track agriculture over really large, very complex landscapes across Africa. We need to combine all sorts of data sets and deliver them in platforms that enable a decision maker, in this case, also including the farmer, to make a good decision about how to proceed in the season. And so, you know, the backdrop of all of this is that space technology is critical in addressing agriculture and food security more broadly, not only in Africa, but globally. We need to be able to predict disasters. We need to be able to make distinct, clear assessments of the impacts, projected impacts. We need to be able to determine what people need to be paid out for their investments or things that they've lost. We need to be able to understand what sorts of measurements we can take or programs we can take to improve soil productivity, for example. We need to be able to understand shortfalls in productions and what those mean for larger areas, as well as areas that might not be directly in line of events like Cyclone Idai that will have cascading impacts. For example, increased exports to supply a particular region that's been impacted extensively. So space technology is really critical in this, in us getting to 2050 in a way that we can deliver information to a farmer. In order to get there, however, we need to make very strict decisions, very intentional decisions about the things that we invest in. We not only need to invest in research for social benefit, we need to have equitable access to information and data. We need to be able to deliver this information to the farmer in a context and through a medium that is accessible to them. While we might create really fantabulous maps and products and enable policies being made by large organizations, we still need to make we need to be able to deliver that kind of insight to the farmer to make that decision where it matters the most, the person who is on the ground. At the same time, we need to have financial mechanisms to not only support the tech development, but as well to support improvements in agriculture, including, you know, better seeds that are more appropriate for the upcoming seasons. And while we're making extensive impact across large areas, influencing and supporting decision-making processes across many African countries and in other places around the world, we still have a long way to go. We still need to be able to sustainably, continuously, and extensively invest in the development of innovative technology, at the same time delivering it to the people who need to have the information to make the decisions. And this is my this is the end of my slides, and I'm looking forward to the discussion. Thank you.
Excellent. Thank you, Catherine. We really appreciate your insight. Paul, I'll pivot back to you to see if you're able to share your slides. Oh, you're on mute.
Can you hear me now?
Okay, we can hear you now.
Great. Let's see if I can get these slides finally to be shared.
And while you're doing that, I'll just highlight, I think Mishak and Dr. Sharif, I think the insights that Dr. Catherine shared with NASA Harvest, which is not only in Africa for Victoria, there's also programs in South America as well. I think the NASA Harvest information is very helpful, especially in Africa and South America, where there's still a lot of agriculture grown by families and small plots. And so her program that she administers, she focuses primarily on Africa, but NASA Harvest is around the world. So there could be some great synergies for all of you in this. And I know, Dr. Sharif, you do programs around the world as well. So Paul, back over to you if you were able to get your slides up.
I'm not sure it's working. So let's
there we go. They're coming up now. Excellent.
Great. Thank you. I was about ready to change the laptop, so this is good. So anyways, thanks so much for your patience and for inviting me, Shelley. And I'm amazed by the quality of the presentations from all the experts. So it's an honor to be part of this group. So I really want to take a look at things little more from the financial and investment perspective, because there's quite a bit going on among public companies that are trying to be very proactive in working in the space, and some names that you might not be expecting. So let me start by moving forward on some of my slides. And we have a very important partnership I'm going to begin with between Deere and Company, the John Deere tractors, for example, and SpaceX. And one of the things that distinguishes Earth imaging satellites and their significance from other types of satellites is that some of the applications are really critical, like aiding disaster response, supporting agriculture, monitoring the environment, assisting with urban planning. And in this particular situation, John Deere's customers, who are largely farmers, will be gaining access to the broadband capabilities of SpaceX. It's going to be rolling out in the second half of this year, starting in the United States and Brazil. SpaceX is a global broadband service. This has the potential to become a global product that can reach people from all regions of the world. We also have a very important situation with resolution. We have resolution expanding pretty dramatically. And we have situations where, for example, the Landsat 8 satellite, which has very important imagery that's able to provide important services. For example, some of the things you've seen in other presentations show some of the great advances that you can see with mapping and also with imaging. And they involve things like looking at the coast, seeing where water is located and signs of life. It can help with real-time data and disaster relief, and also other areas. That's got great potential going forward into the future. A further issue that's come up, and it's very important, is artificial intelligence and machine learning. These are modern technologies, some of the big advances taking place in the world right now, and they tie directly in to what's offered in space and with satellite capabilities. So for example, with artificial intelligence, you have NASA and IBM using AI to process geospatial data for various applications. There's also, for example, the effort to use the IBM environmental intelligence product to provide temporal data for analytics, to conduct complex and efficient queries to reveal relationships between layers of data. This is getting to be quite sophisticated. You also have IBM aiding the AI geospatial solutions powered by NASA's Landsat Sentinel-2 satellite. And there's also focus on detecting crop problems and identifying floods, which really are, quite pervasive. They're not only happening in Africa, but also right now in Central Europe. So a very important technology that can make life better and help with emergency response and other measures to aid people. Another thing to point out just briefly is geographic information systems. They consist of integrated computer hardware and software. They store and manage and analyze and visualize geographic data, and they also enhance mapping. Next, we have the integration of augmented reality and virtual reality. I remember 20 years ago when I was a young person getting started in my career, we had virtual reality and it became more of a concept. And so it was very experimental. I was searching far and wide to find experts who could talk about what it would be like, because it really didn't exist in very many places outside of universities and labs. And now you've got the great augmented reality and virtual reality. I tested it out at the Satellite 2024 conference back in March, and it's pretty impressive. So it creates an immersive experience in minutes with real-time localization and augmentation, and it's going to be an exciting part of the future. 3D mapping is also in a very important situation right now, where you have the enhanced visualization of Earth. It can revolutionize sectors from autonomous driving to climate modeling. Examples include NASA's use of it to assist in their efforts, and it also uses some of the finest engineering and space flight hardware for providing this kind of remote sensing. Challenges and considerations. Data management addresses the handling of massive data sets generated by these various technologies that I've described. There are also privacy and security issues that we need to consider. They include ethical considerations of high resolution, real-time Earth observation, and others. And further, we have important future prospects. We want to encourage international collaboration for global benefits, including many of those discussed today. Also, you have things like the UN Science Summit, which itself is a platform for such cooperation. And it's always important to engage the next generation in youth. I've been involved in the Society of Satellite Professionals International, and they're always looking to get the next generation excited about space. And we have so many entrepreneurs who have put their resources into things like SpaceX and other advanced companies that require, really a billionaire to help fund it. And then that's very important to keep exciting the next generation so that some of the top talent will go into areas that are important that we're discussing, things like the imagery that now is available, remote sensing, 3D mapping, the use of AI. There are a wealth of opportunities available in the future, and it'll be exciting to be a part of that for all of us. And then in conclusion, space technology is important in understanding and managing the Earth's resources and challenges. I know that's a concern pretty much echoed by everybody who's spoken so far, and it certainly is one of my own. A recommendation would be increased integration and accessibility of useful Earth observation data to aid in global policymaking and sustainability efforts. And then I think it's also great to always thank people. So I want to thank Shelley and Kim Degnan for inviting me, and all the other speakers for giving their incredible explanations about what's happening in their regions of the world. I'm happy I could share some things from my perspective. Thank you so much.
Well, thank you, Paul. It's been a pleasure. And that was really insightful, as you said, sharing that. And of course, we have coming up, not last or least, is our amazing Victoria Valdivia. And she's kind of representing multiple continents because she's in Chile, so she's South America, and she is a global fellow for the European Space Policy Institute. And she's a big advocate and leader in space in Antarctica, and just led a sidebar at the annual SCAR policy event, which is on Antarctica every 2 years that Chile hosts, and she did a sidebar on space for Antarctica. So Victoria, the floor is yours. I hope that in your few minutes you'll be able to talk about those 3 continents, if not more.
Thank you so much, Shelley. I'm very happy to be sharing the stage again with you and with all my awesome colleagues here. So I will try to be very, very quickly about this. And yes, for sure, I will talk again about the merge between space and Antarctica. As you told, Shelley, living in South America means we're currently facing a lot of challenges coming from climate change, phenomenon, but also regarding this quickly involvement on development and technologies. Okay. So what we are trying to reach here, well, as you know, Chile is closer to Antarctic territory, but also we have a huge portion of coastal areas. So we have a lot of people living on islet, but also on coastal population being for sure impacted during the challenges of the climate change, such as the rising level of the oceans, the rising temperature in the worldwide perspective. And in our case, in our special case, we are also so connected with the Antarctic continent. So any change happening over the Antarctic surfaces is impacting on territorial continental continent of territory of South America. It means in the continental side of Chile. So, for example, just this year on the Antarctic Peninsula, we didn't have snow. And that is meaning that now our spring in the central latitude of Chile are being so different than from the historical perspective, increasing the possibility to face natural disasters, but not because something weird is happening just on nature. It's about the capability of population to adapt and being resilient regarding this kind of change on the territorial phenomenon, but also the connection with society. So I'm talking about this because I want to address a very important issue. On space activities, we used to think and to talk about space sustainability, but always just looking on everything happening in Leo, also much congested is Leo, Mio, and in the future potentially Geo. But we are not so familiar with the side effects of this more polluted orbital regimen. So what is going on? Everything happening in outer space will have an impact over Earth, but also over population here in our home planet. So I want to talk about the accumulation of space debris over Antarctic territory. There is a special maritime area called Point Nemo that is located in the South Pacific Ocean. And yeah, you can see here some details about the Point Nemo. But Point Nemo was designed as a space cemetery during the 70s by international community because it's truly isolated from any inhabited area of the world. However, nobody take care, so nobody noted that Point Nemo is also a very, very, very important maritime area where several oceanic currents are converging and interacting. One of them is the Antarctic Circumpolar Current. So the Antarctic Circumpolar Current that is situated in the Point Nemo is maybe the most important oceanic current because this current has the capability and has the capability to sharpen and to control and to determine everything happening in the coastal areas of the Antarctic continent. And if you can remember, the Antarctic continent is protected under several international treaties, particularly one environmental protocol to the Antarctic Treaty System, also known as the Madrid Protocol. So Antarctica is a key component to regulate the worldwide climate. And through that, everything happening in Antarctica will be impacting over worldwide population, not only in South America, not only high latitude territory, but also, for example, in Europe, the United States, and everything because we are living in an ecosystem, in a connected ecosystem. Nothing happening in one point will not having side effects or over other territories. So what is going on with us? The accumulation of the space debris is creating some phenomena over the Antarctic circular current, and this current is changing the coastal areas of the Antarctic. For example, the ocean acidification led by this current is determining the ice melting of the permafrost in Antarctic. So that is very dangerous, but also this phenomenon is having some collateral or side effects over human security, international security, the potential of on the future of the peace on Antarctic, but also on the operational field, as you can see on the screen. From the third perspective, due to the interaction with the oceanic currents, I mean, we are literally throwing a space debris directly to the ocean floor on Point Nemo since 1970s. And nobody's measuring how about tons are being accumulated on that, or which kind of side effects will have this regarding the biomass, the oceanic ecosystems, and which kind of iteration will have it regarding some economic activities such as fisheries, access to food, and in coastal population, etc. So in the aspect of the human security, the first thing that we need to address is which kind of impact is having this space debris accumulation on this oceanic current for food security and primary activities such as the fishery of coastal population, particularly regarding that the first impacted population will be the closest ones to Antarctica, such as I'm thinking about Argentina, Chile, and third countries that also are developing countries. Because you must remember that Antarctica has 5 entry gates, and from those 5 entry gates, at least 3 are developing countries. So we are talking about vulnerable population that depends extremely on fisheries sometimes, but also the fishery provides the principal access to food. So we need to make sure if that fishes are being contaminated or not, or which kind of effect will have this kind of components coming from outer space into the water regarding the health and the rise of, for example, certain kinds of diseases on those population groups. The second aspect is that the major creation of space debris is jeopardizing the confidence and trust among international actors. So it's having an impact on the international security as well, increasing uncertainty and raising challenges to reach the consensus. Antarctica is protected under a very particular multilateral governance model, such as is the outer space activities. However, outer space community is not talking, is not interacting with the Antarctic community. So we are adapting different measures, different norms, different regulations in both communities by separately. But now we know that potentially all the activities being conducted on outer space activities that for us are regulated, controlled. Well, of course, we have several challenges regarding outer space and other issues, but most of our activities are under this umbrella for peaceful uses. However, those activities are interacting with the regulatory framework of Antarctic, and in particular the environmental protocol. And the environmental protocol was designed in order to protect Antarctic and to keep and strengthen the peace in Antarctic continent and connected ecosystem. So regarding that, we are basically the same actor, I mean, same countries conducting space activities in outer space activities, but also conducting activities on Antarctic. For example, any country will be capable to denounce for violations to the environmental protocol throughout conducting an intensive space activities, for example, in Leo, and observing a rising number of re-entry components going directly to Point Nemo. And that is very easy to know because Point Nemo is, as a space cemetery, is a place to control re-enter maneuvers. So for sure, at the international system, international level, we have certain kind of awareness who is re-entering what, and if those space platform, space component have partially re-entered, entirely re-entered, unboarded completely during the re-enter mission, because we have this these accomplishments to make it transparent and to confidence building of space activities. So, I mean, the data, the information is available because it's public, and but this lack of interaction between both communities could arise the mistrust and lacks on international confidence measures on Antarctic area. So jeopardizing the international model that is key to keep the peace on this continent. Then we have that the creative space debris is increasing the re-entries interacting with the environment of Antarctic and association ecosystems, raising the potential of international dispute, as I was telling you, under the umbrella of the Antarctic Treaty System, but also jeopardizing the environmental protocol. Besides this perspective on international disputes, because we must remember that both treaties were created to preserve the peace at the international level. Besides that, we also must strengthen that more intensive space activities will be creating more levels of space debris, and through that, more space debris coming back, re-entering into oceanic areas. So we need to think about how we can stop, how we can clean, how we can prevent, being vigilant, being conscious, and raising awareness about the associated risk. Because yes, for sure, we need the data, we need the info, we need all the support, all the benefits coming from outer space to improve resilience here on Earth for people. However, we cannot jeopardize, we cannot create more hazards, more risk to the life of people on Earth just because we are prioritizing the access to information. We need to address why we need that information, which is the principal purpose, and to harmonize this kind of activities with the future and the potential futures for population, particularly in coastal areas and vulnerable regions. The Antarctic, and the number four is that the Antarctic circumpolar current is a key for the regulation of the worldwide climate, as I told you. But also it determines the climate of Antarctic, impacting the shape and characteristics of the continent and the operational security of people performing activities under the umbrella of the ITs. And this point is very important for me because I'm trying to harmonize all my different positions, all my different backgrounds with that. I mean, Antarctic is a very special area. It's not only a continent protected for peaceful uses, for scientific uses, but also Antarctic is the closest continent to outer space, because Antarctic has several geographical characteristics that make it special, like high latitudes, but also high altitude. It's a closer territorial land to the Leo orbit. For that reason, Antarctic is very particular, it's very useful for the future of space security, but also space safety, to improve operational safety and security of space operation. But jointly with that, Antarctic is a very isolated continent, very challenging for human life support, and all the people conducting activities under the umbrella of the Antarctic Treaty System, being scientific activities, they are doing that in order to strengthen the international collaboration, the prevention of international disputes over Antarctic territories and resources. So they are a key component. We need to keep them safe and return them safely to their original countries. And being an isolated area, for sure, there will be a rising hazard for search and rescue operations, SAR and CSAR operations. So any kind of lags, disruption, denial over satellite services such as PNT, communication, satellite imagery, and all, will be impacting directly on the operational safety and operational security of scientific conducting activities in order to strengthen the peace. So we must take care about what we are doing in outer space, because for sure space is getting congested, but also uncertain, and the emergence of some capabilities such as counter space capabilities and the exploitation of outer space domain through during the international or interstate conflicts is created several challenges that not only also impacting space platform, but also is impacting the life of people in isolated territories such Antarctic. But Antarctic is a key component to avoiding international dispute, particularly in this kind of uncertain times that we are facing at the international level. So as a final remarks, I want to address that in first term, we need to think about the application of the concept of liability. We have two major liability conventions regarding this merge, one from the side of the Outer Space Treaty System and the other on the Antarctic Treaty System. And the liability convention from Outer Space Treaty System is focused on any kind of damage that space activities will produce over population, critical infrastructure, but and also over certain kinds of interests of the state. So, but to be successful on its application, the liability convention demands someone denouncing this kind of issues. So we need to raise consensus about if we want to apply this convention over space debris coming down, in order to address certain kind of compensation over impacted population or not, but also from the side of the Antarctic Treaty System, this concept of liability comes directly from the Protocol to Environmental Protection. So this protocol, the Protocol of Madrid, identifies clearly this concept of liability. No one, despite their final goals, their proposals and all the Antarctic connected system and Antarctic environment must be protected. If you are not doing that, you are basically against the protocol, and you are being a subject of the international denunces and sanction and all the mechanisms regarding soft power. So,
Victoria, we're running out of time. You got 1 minute.
Okay.
1 minute.
Okay.
We're running out of time.
As a point number 2, safety and security for international peace. I mean, in the core of all space activities, Antarctic activities, and this merge is the safety and the security, the possibility to improve life of people here on our home planet depends on the capability to harmonize the development of technologies with the need to protect our environment. I mean, we only have one single planet. I mean, we are not living in Mars but for now, this is our home planet. This is the only one that we have. We need to protect them, and we must take care about developing population, more vulnerable population, facing the consequences and maybe not exploding in the same way the benefits of space activities. But people living in coastal areas of the South Pacific is now.
Victoria, I need you to please wrap up on your points.
Okay.
I'm sorry, we're out of time.
Okay, so finally, the need to strengthen transparency and confidence building on the re-entries activities. So my final proposal is to go through the creation of a platform in order to measure how many pieces of space debris we are accumulating in these areas, and offering to scientific community access to this data in order to improve the researchers and the decision-making process based on evidence. So that was all for my side, Shelley.
Excellent. Thank you so much for sharing that. And I think as we're wrapping up, I think what was really great about your final remarks is there is still a debate going on about deorbiting the International Space Station, which is supposed to take place in 2030. And what will that deorbiting be? Is it going to be into the Pacific Ocean? There are other groups that say, no, we should super sink it into space. So the discussion you've brought up is very relevant. It is still being discussed not only for the orbital debris that is coming down and being sunk by Antarctica, but it's also a bigger case as we look at deorbiting ISS. What I'd like to do in the last few minutes is thank all of our speakers. You were all amazing, the great insight. I'm going to capture a couple screenshots here real quick that I'll share. So one, you all look fabulous. 1, 2, 3. Excellent. And I want to thank you all for joining us. I know for Masami and Professor Gao, I know this was very late, and I want to thank all the individuals who got up very early to join us. Kim, I'm grateful that you gave me the honor to be the moderator of this dynamic panel, and I'd like to give you the closing words.
After all those wonderful presentations, I truly do not have much to say except to thank you all for all of your effort over these last few months to help us organize this fantastic panel. I have a million questions, and I know that our many attendees do too. Unfortunately, we're out of time. Shelley, is there one question that you might want to pose to the panelists? And let's just push the envelope here. We have 2 minutes.
Okay, 2 minutes. I really think I'd like to key back on what Professor Gao talked about, because it came up in all the talks about the data, the sharing, the artificial intelligence, machine learning. So Professor Gao, since you stayed on the line, share a little bit about where you see space and AI in that intersection, because I think some people are still not aware of how that deep tech is part of space.
Where AI, right now say AI for everything. So AI become more and more popular, more and more important. But don't forget that without big data, I think AI cannot play a very important role. So data, including earth-spatial data, should work with the AI, work together for our SDG monitoring and evaluation.
Excellent. Thank you so much. We're right on time. Kim, thank you again for your amazing leadership. We look forward to joining you for a future session. And to all my panelists, we're grateful for your insights, and we look forward to continuing the collaboration to use space to better life here on Earth. I'm Shelley Brunswick. Until next time, I look forward to seeing you around the galaxy.
Bye.
Bye-bye.